Stars evolve in different ways. There are many different stages in a star's life. But not all stars undergo the same stages as others. A star's life cycle depends on its mass. The larger the mass, the shorter its life cycle. The amount of mass that a star has depends on the amount of matter that is present in its nebula. In this film, we'll be focusing on low-mass stars, stars with 0.08 to 0.04 solar masses, something that looks a lot like this. And here's the Sun. Small, right? Now, let's see what its fate will be.
Low-mass stars are stars that only have 0.08 to 0.4 solar masses. This means that these are less than half of the Sun's mass. Over time, the hydrogen gas in the nebula is pulled together by the gravity and it begins to spin. As the gas spins faster, it heats up and becomes a protostar. This is the first stage of the low-mass star's life. This is an example of a protostar.
A protostar looks like a star, but it is not a star yet. Why? Because its core is not yet hot enough for fusion to take place. The luminosity comes exclusively from the heating of the protostar as it contracts. Protostars, as we can see in this photo, are usually surrounded by dust, which blocks the light that they emit, so they are difficult to observe in the visible spectrum.
After being a protostar, stars evolve into a main sequence stars, like this. So, a protostar evolves into a main sequence stars or a sun-like. So, a main sequence stars fuse hydrogen to form helium atoms inside their core. About 90% of the stars in the entire universe, including our sun, are main sequence stars. These stars can range about 10 times of the sun mass, up to 200 times as massive. But low star masses cannot completely do all the things with an ordinary star does. Things are different between them. Thus, they are called red dwarfs, or sometimes it is called small main sequence stars.
Smaller bodies with less than 0.08 sun's mass cannot reach the nuclear fusion. Instead, they become brown dwarfs, the stars that never ignites. But if the body has sufficient mass, the collapsing of gas and dust burns hotter, eventually reaching the temperature sufficient to fuse hydrogen into helium. The star turns on and becomes a main sequence star, powered by hydrogen fusion. Fusion produces an upward pressure balanced with balances of inner pressure caused by the gravity to stabilizing the stars.
How long a main sequence star lives depends on how massive it is. A star that has higher mass may have more materials, but it burns through it due to its higher core temperature caused by greater gravitational forces.
Red dwarfs are small, low surface temperature main sequence stars with a spectral type of K or M. It is their low temperature which dictates their red appearance. Their small diameter, typically a few tenths that of the Sun, means that they are also faint. Because they are so small and have such low mass, they evolve slowly with estimated main sequence lifetimes of 100 billion years. This long lifetime means that there are many red dwarfs. Indeed, they are amongst the most common type of star. An example of a red dwarf is Proxima Centauri.
Brown dwarfs usually have a mass less than 0.75 out of the Sun, or roughly 75 times of Jupiter.
Many astronomers draw the line between brown dwarfs and planets at the lower fusion boundaries of about certain Jupiter masses. The difference between brown dwarfs and stars is that unlike stars, brown dwarfs do not reach stable luminous bithermal nuclear fusion of normal hydrogen.
Both stars and brown dwarfs produce energy by fusion of deuterium in their first million years. The cores of stars are continued to contract and get hotter until they fuse the hydrogen. However, brown dwarf stars are preventing further contraction because their cores are dense enough to hold up themselves up with electron degeneracy pressure.
And now we will see how exactly these low-mass stars evolve.
So here's a simple simulation of how low-mass star evolved throughout its lifetime. So as you can see here in the star in a box software, it is set in mass as 1. So first, let's change the solar mass here. So let's change it to 0.2, an example of low-mass star. So after the protostar, as you can see here, you will see the main sequence star. And as we play, the mass of the main sequence star is increasing. When the time it goes out in the main sequence, it will become a red giant-like or a red dwarf star. The mass is very small because of the collapse due to gravity. Therefore, the pressure is very high and the temperature also is very high. As you can see here, the thermometer bursted. Since the color is white, we all know that the white stars are very hot. There you have it, the fate of a low-mass star.
There you have it!